class, it's Professor Rourke. So I wanted to make a video from one of the questions in the 3.2 interactive assignment. I have also recorded a pretty long video about 3.1 and talking about 3.2 as well. But I think we can take all the help we can get on 3.2. So I wanted to make another video in case that would be helpful to us. Okay, so this question says, is a measure of 30 inches, quote, far away from a mean of 18 inches? As someone with knowledge of statistics, you answer, it depends, and request the standard deviation of the underlying data. All right, so that's a little contrived, but whatever, we'll go with it. Long story short, we find out that from this data, the mean is 18. Okay, so what I'm going to say is, and they don't really say, is it a sample or a population? I don't even know. So I'll just go with a population. It doesn't really matter for this particular problem. So the mean is 18 inches, okay? And then they also say the standard deviation is 3. And then the question is kind of like, how far away is 30 from 18 if we're counting by standard deviations, which are 3? Okay, so I know, again, at first in the beginning, it sounds very complicated, but I'm always going to ask you to do a couple things. And it's going to be annoying, and I'm sorry in advance, but I'm going to ask you to sketch a normal curve. Okay, so for any of these problems, whenever you ask me for help, I'm going to say first, I'm going to be like, can you please draw a normal curve? And then right in the middle, we're going to label the mean, which is 18. And then I want you to get me 6 special numbers. I want you to take the standard deviation and add it 3 times to the right. And then you're going to take the standard deviation and add 3 times to the left. And then those numbers are my special numbers. Okay, so because standard deviation is 3, I'm going to start with, you can do this a couple different ways, but what I do is I take 18 and I add 3. So 18 plus 3 is 21. 21 plus 3 is 24. And then 24 plus 3 is 27. Okay, so I've done my 3 numbers to the right, and now I do 3 numbers to the left. Okay, so my special numbers, this is what I do. Then 18 take away 3 is 15, hurts a little bit more sometimes when we're subtracting. 15 take away 3 is 12, and 12 take away 3 is 9. Okay, so I have all my special numbers for this random problem. Great, okay, so I still don't even know what we're talking about, but whatever. 18 inches, 30 inches, I'm not really sure. So anyways, long story short, the question really is how many standard deviations is 30 inches from 18 inches? So this is getting, again, to the heart of the problem that we can draw this empirical curve. We have the special numbers. The special numbers go from -3 standard deviations to +3 standard deviations. And 99.7% of the data is within 3 standard deviations. Okay, so when we say within 3 standard deviations, we mean we're talking about going from -3 standard deviations all the way up to +3 standard deviations. 99.7% of the data is within there. Okay, so not a lot is outside of there, correct? However, this is because they say 30 inches. So we had to add like 18 plus 3 to get to what 3 standard deviations is. If we added 3 again, we would get 30. Okay, so let me see plus 3. We'd be at 30 over here. 30 is pretty far away, especially because the standard deviation is 3, and we knew that if we got 3 standard deviations above and 3 standard deviations below, we'd be between 9 and 27, would have 99.7% of the data. 30 is 1 more standard deviations beyond that. 3 standard deviations is very far off the scale. Okay, it's real far out there. Okay, so what we would say, I hope this makes sense, is this is 4 standard deviations away. Okay, because again, it's how many times we'd have to add 3, which is a standard deviation, to 18 to get to 30. So we'd have to add 3 4 times to get to 30, to go from 18 to 30. So that's why it's 4 standard deviations away. Okay, and then it says, is 30 inches far away from the mean? And then we would say yes, because 30 inches is more than 2 standard deviations away. Usually, they kind of tie a bunch of things in here, but anything outside of the 95% range is not like usual, right? Like usually they say anything within the 95% range is pretty usual. It wouldn't be anything out of the ordinary. Anything outside of 2 standard deviations, think about there's only like a little more than 2% of the data to the right and 2% of data to the left of our 3 standard deviations in our 99.7 rule. So it wouldn't be very likely. Okay, and then the question says, suppose the standard deviation of the underlying data is 9. is 30 inches far away from a mean of 18 inches. So now they're giving you a totally different problem. Okay, so now they're saying instead, if we had another normal curve that I'm going to ask you to draw because I know it's rather annoying, but if we had another normal curve and we still had the same mean of 18, okay, but this time the standard deviation's 9, we're going to have new special numbers. Okay, so if 18 is in the middle here and the standard deviation's 9, I'll go ahead and start drawing my special numbers. 18 plus 9 is 27. 27 plus 9 is 36. Oh, 36 plus 9, painful, it's 45. Okay, so those are 3 standard deviations to the right. We could also do it from the left, okay, but we're going into negative zones here because we could go below 0. I don't think that even really makes any sense, but that's okay, whatever. Um, okay, so now the same question though is saying, okay, if the standard deviation was 9, is 30 really far away? Well, 30 now, if I change these special numbers, actually 30 happens between 1 and 2 standard deviations. So it's still above average, right? It's still above 18, but it's not that far off the normal scale of things, okay? Because before, when standard deviation was 3, you can see 30 is all the way off to the side. Didn't even fit into my special numbers. But now that it's a different standard deviation, 30 is in there. 30 is just between 1 and 2 standard deviations, which is fine. Okay. So if standard deviation was changed to 9, the question is 30 inches far away from a mean of 18 inches? So you would then say no, because 30 inches is less than 2 standard deviations away from 18 inches. Okay, so I hope that makes sense. Again, this is from the interactive assignment, and I'll add this timestamps to the other video that I recorded, just waiting for it to like buffer or whatever. And so hopefully you can also jump to the part of the video where I talk about this normal curve empirical rule situation. All right, thanks class. Have a good one.